momentarily. We'll be starting momentarily. In the meantime, if you want to give yourself a quick intro in the chat box, including your name, position, and what you love to do, that would be great.
Thank you. Okay, let me share my screen. Can you see my screen?
It's dark. Yes.
Okay. So welcome everyone to the IEEE Young Professionals Silicon Valley Startup Special Interest Group. My name is Joseph Wei, and I will be giving you a quick introduction of this group. Start out with a little bit of IEEE introduction for some of you who are not familiar with IEEE. It stands for the Institute for Electrical Electronics Engineering Association. And we have about 400,000 plus members worldwide with 39 technical societies in 160 countries. And there's a lot of conferences, over 1,600 conferences, and over close to 4 million technical documents and 170 cited periodicals. If you file patents, so you'll be familiar with where IEEE is the lead in the cited publishers in your patents, about 3 times more than the second magazine. So the Startup Special Interest Group mission statement is to foster a network of experience and also young entrepreneurs to share ideas and best practices and to collaborate on startup opportunities. So we plan to have monthly webinars like this one, and we're working on a mentor-mentee matching program. And also we run a startup pitch competition at least once a year. So that will be announced shortly once we're ready. And here's the website you can go to look up more information regarding upcoming events as well as past events. So the first general question, let me preempt it. This webinar will be recorded on Zoom, and the Zoom recording will be posted around 48 hours on this website. And if you want to join the mailing list to get a notification for future events, please click on this link, and this is also available on this website. And if you have any suggestions for webinars topics or other type of suggestion, as well as you want to volunteer for this group, please send me an email. And this is actually the team that helping to, we are volunteers to help to put together these programs. And thank you for attending this meeting and the webinar, and I'll pass on to Wendell.
Great, thank you, Joseph. I'll be doing a quick intro of IEEE Young Professionals. So IEEE Young Professional is a social networking, and we host social networking and technical events for those who graduated within the past 15 years. In terms of social events, we have a happy hour, hiking, and volunteering events, and board game nights. And in terms of technical events, we focus on technical areas that most of our members are interested in, including hardware, software, robotics, and AI. And in terms of networking events, YP has a presence in most major conferences, such as ISSCC, TAMS, and the GHCC. So please follow up our meetup page or our website to keep track of our upcoming events. 2 of our upcoming events is a hiking at Stanford Dish, as well as a IP management talk as part of the Startup Special Interest Group program. So these are very outstanding events, both in the both as a social events as well as a technical IP management. So if you're interested in those topics, please scan those QR codes as well. They will be posted after the event. Alternatively, you can keep track with us on our meetup page or our website. Last but not least, it's my pleasure to introduce our speaker today, Mike Keer. Mike is the founder and managing partner of Product Realization Group, which has 30 years of experience bringing high-tech electronic products to market, both for startups, growth stage companies, as well as established companies. Prior to PRG, Mike held engineering and management positions in various companies such as NCR, Ericsson, SemiPower Systems, and Paramit EMS, where he participated with over 100 new products. Product Realization Group guides the world's most innovative companies to accelerate delivery of their products from concepts to market. And we know that they have a team of experts that help with technical PM resource as well as risk management, among many other things. And personally, I know that PRG has helped many companies in various sectors, including medical, communication, consumer, and industrial. So let's give a virtual round of applause for Michael Keer. Mike, the stage is yours.
Thank you, everyone. Nice to meet everyone. We'll go ahead and share the screen here. All right, is that, can everybody see that?
Yep.
Very good. All right, before we get going, it'd be nice to get some idea of how many in the audience have already been through some level of product commercialization from the, the beginning to the end. So if you don't mind raising your hand, just making some kind of a signal so I get some idea of, the level of expertise in the audience, that'd be great. Great. So it looks like a few, probably more as well that maybe just didn't. Yeah, it looks like we got a few there. Fantastic. Okay, I was already introduced, so I'm going to skip over my introduction here. But 30 plus years of experience. He also talked a little bit about product realization group. I will just add that everybody on our team has minimum 20 years of experience, so we're very experienced team of experts in the commercialization of physical products. And we're shifting very heavily into mission driven right now. So I'm really focusing on clean tech, sustainable, and med tech product development activities. All right, so what is the industry challenge that we're trying to solve? And I've got a chart up here of what I've seen over the last 30 years, especially with earlier stage companies, and kind of walk you through it here. So companies, maybe they spin out of a lab, university, garage, whatever the case may be. It's very typical that they're going to want to conserve cash. Maybe they haven't raised a lot, or they're used to not spending a lot. So that they'll go very lean. And I've heard the expression, how hard can it be, for hardware products? And eventually they'll miss the launch date. And then there's a tremendous amount of pressure to do everything that's required to make the product shippable. And that's going to take a lot of money, more time than they anticipated. And by the time the product does ship, it's late, it's over budget, and it doesn't meet all the requirements. So this is a very typical scenario that I've seen many times over the years. And the intent of this presentation is to give you some ideas, some best practices that I've learned over the last 30 years of what are things that you can do to not fall into this trap and to really obtain a competitive edge in the marketplace. So that's really what we're trying to get to. So from shipping late, not meeting requirements over budget, to what I call proactive investment. By doing that, by doing the right things at the right time, you can get the right product market fit. You can improve your time to market, meet your launch date, mitigate risks early, lower your costs, and develop resilient and robust supply chains. And I would argue by doing all those things, you can maintain and sustain a competitive advantage over not just your first product to ship, but over multiple generations of product as you go through the business cycle. So if you're following this methodology and your competitors are following this, you're gonna maintain a competitive edge over time. Okay, so then you may ask, well, why is it so hard? What makes it so difficult? And it's so difficult because there are a lot of different things that need to be done in general, and then there are a lot of different things that need to be done sequentially. So I've listed a few here. These are some of the main things that companies need to do to get products to market, starting with concept market feasibility, things like market validation, go to market, product management when you're in planning and design, program management as you get into development, validation, and then all the way through operations and supply chain. There are a special set of things that you need to do for medical specialization. So things like FDA regulatory, quality management systems, and so forth. So if you look at this gives you an idea of, why is it hard? And a lot of companies don't know what they don't know. They don't know all the things that they need to know, and then they fall into these traps of not doing, for example, regulatory, or not understanding quality management, and then failing, and then that takes more time and more money, and they end up bringing products to market late and over budget. Okay, so what I'm going to focus on here during this talk is what are some of the very specific practical things you can do in the development process. And just to be clear, I'm not going to talk about marketing. I'm not going to talk about go-to-market. And the assumption in this presentation is that you've already got some idea what the market fit is and what the product is. And this is really going to be about execution, starting with concurrent engineering, agile hardware development, and then cycling through all the way through operations and supply chain. So it's really about execution. So you got a product, you got a market. Now, how do you actually execute following a set of best practices? All right. So I usually start, and I think it's probably good to do this with a question, which is, for those that are in the middle of developing a product, what do you see as the number one challenge facing you getting your product to market? And I'm happy to open it up to questions. If you got want to share, maybe we'll take a couple just to tee things off. Feel free to raise your hand, or I don't know if you allow speaking there, Rio, but open it up. If anybody wants to share, if not, I can move on to some of the challenges.
I think most of the attendees are muted. So
everybody's muted. Okay.
For the attendees who are interested, maybe you can post something in the chat.
Yeah, you could put something in the chat. In the meantime, I'll assume that you're not able to vocalize, and I'll keep going here then. Yeah. Okay. So what are the warning signs? These are 10 of the most common ones that I've seen throughout my career: slipping schedule, over budget, not hitting the cost target, missing requirements, and/or feature creep, especially when you're talking about technology-focused companies, rapid team growth, breakdown in communications, customer beta test failures, low yields, high number of pre- and post-launch ECOs, field failures, and some of these and all of these are going to ultimately lead you to that first graph that we talked about. And an example of this is, I don't know if anybody remembers the company Pebble Watch back in the day, but I knew the founder, and I had tracked it as they raised money, and over the years they raised over 45 million. And one of the things I noted early on was they raised a lot of money, but they really were struggling with execution. So they hit almost every single one of these. They were 6 months late to market. They were over budget. They weren't able to manage supply chain. They grew their team very rapidly, et cetera. And net is they, raised 45 million, but at the end of the day, they weren't able to sustain a viable company. They ended up selling at a loss. So if you don't do these things right, it can really kill your company. And there's many examples of what I call high-tech roadkill all over the place. I'm sure you know many of these as well. So if you see any of these warning signs in your own company, I'd urge you to pause and reevaluate then, and then we'll share some of the best practices as we go forward here. Okay, framing it is in terms of how you go about commercializing is one of the key things is understanding your markets. And when I say understanding your market, I'm not talking necessarily about go-to-market strategy. I'm really talking about, in the context of executing, understanding where you're going to ship product will then define what kind of regulatory requirements you need to meet. It's going to define where you want to manufacture. It's going to define your logistics, your shipping. So this is really important, and I've seen it, especially earlier stage companies that don't have a lot of budget. It can really catch them up because they try and ship to too many places too early, and it kills the budget, right? I mean, because every country you have to meet regulatory requirements. Some countries require in-country manufacturing content. So yeah, my recommendation, kind of high level takeaway here is get an MVP and then make sure you're really not hitting all the markets at the same time, but understand your go-to-market strategy and ideally hit the biggest market, the most productive market you can, and then you can always expand out from there. Yeah. Okay, and the other thing that very common over the companies that I've worked with and my 30 years of experience is companies underestimate cost, right? They tend to think of cost, especially people that haven't been through hardware development. They tend to think of cost as material cost, maybe material manufacturing. And the analogy I use here is think about if you're building a house and there's a pile of wood on your lawn, that's not a house, that's a pile of wood on your lawn. And it's the same analogy for material. A pile of parts in a warehouse is not a product, it's a bunch of material. So when you're considering developing, commercializing a product, you got to think not just about material costs, but manufacturing costs, total cost, life cycle cost. And by doing that, you'll get a much more realistic picture. It may not be one that your investors are happy with, but if you don't get that picture early, you're going to underestimate your overall cost. You're going to run out of money, and it's likely you will not be able to raise more investment as you go down the path. So this is really really critical here. Okay, this is a little cartoon about beta. I call it how not to develop a product. What do you not do? So I'll give it just 30 seconds here for you to take a look at that, and then we'll move on. Or Joseph, when you've read it, Joseph, why don't you signal me and I'll move on. Yeah. Okay. All right. Let's keep going there. That's what you don't want to do. And now let's talk about what do you want to do. So I start with agile hardware development, and a lot of people have heard of agile software development. Agile hardware development tries to take some of the concepts from agile software development, but hardware by its very nature is different than software because, for example, if you want to test a printed circuit board, you've got to put all the parts. You got to have everything together. You can't stop a sprint in the middle like you can for software. So there are differences, but the concept of how do you create cycles of innovation and implement cycles of innovation is similar, right? You just have to do it in a hardware context. So first thing I recommend when you're starting a hardware development project is creating a cross-functional team and getting an adequate schedule. So schedule I have here is it's representative. It's not a real schedule, but a real schedule is going to have all the things you need from development, including things like regulatory, supply chain, reliability, shipping, logistics, everything that goes in all the details that you need, including all the dependencies. When you're talking about hardware development, there's a lot of dependencies. So you want to make sure you have all that covered. When you're developing a team, a lot of tech-based companies that I've worked with tend to focus on engineering. Hey, we've got the tech covered. Isn't this cool? But when you're really going to market with a business, you've got to have product marketing, you got to have sales, you got to have operations, customer support, and getting the inputs of all these early in the product development cycle is very important. For example, there was a company I did some work with a few years back that had a smart treadmill, anti-gravity treadmill, and in the development stage, the width of the product was about 1/2 inch wider than a standard doorway. So by the time they went to ship, they didn't realize that because they didn't have customer field support as part of that dialogue. By the time they went to ship, the only way to get that product into a setting where it was usable was to disassemble it or knock the door out or run it through a window or whatever. So really problematic. Would have been very easy to just get that input early and say, hey, can you make it less than a door width and you can fit it in? And they could have done it design wise, but once a product is designed, to make that fix after the fact, almost impossible. So that's why, getting all these inputs as part of a cross-functional team is important. The other thing that's in parallel with that is development models. And that's really going to depend on your particular situation. Some companies that have a lot of IP, a lot of hardware focus, you're going to want to develop in-house. Other companies, especially when you talk about products that have a heavy software component, IoT type of companies, leveraging CMs, leveraging ODMs, JDMs, can be very beneficial because the value of the business really isn't so much in the hardware side; it's more in the software side. So, but the key takeaway here is what is the right model for your business, and defining that early. Once you're down the development path, making these changes, making these changes later on, again, can be very costly, very problematic. So getting your strategy right up front, getting a team, getting your development model, getting a schedule, are all part of going down the path of following the best practices and avoiding the traditional hardware pitfalls. Okay, and now when we talk about hardware development methodology, I think about this in terms of cycles of innovation. And the idea here is each cycle you're constraining your design space, and each cycle you're closing your knowledge gap. So if you look at this first cycle, let's call that feasibility. You're going to define your requirements, you're going to evaluate, you're going to analyze, you're going to test, you're going to learn. For example, you could lock in an integrated circuit in an electronic assembly. Once you lock in that part, that's going to constrain your design space. That's going to close your knowledge gap. You're going to do some level of testing. You're going to see what works. You're going to see what doesn't work. And then you're going to apply those learnings to the next cycle. And then you're going to test again, et cetera. And typical cycles for a hardware product, 3 is pretty good. I've seen companies do it in a couple. That's very unusual. That tends to be very simple products. And I've seen companies take 5, 6, 7, depending on the complexity of the product and what kind of issues need to be addressed. But the takeaway here is don't underestimate what it takes time-wise and testing-wise to make sure you have the right product, and make sure you have everything tested early. Once you get the product shipping, it's very costly and it's very damaging to your brand to have to fix a product after it's already in the marketplace. Okay, so that leads us to understanding trade-offs and risks. And developing a minimum viable product is something I recommend for all companies in the hardware space. Every feature, every part, every additional complexity that you add to hardware is going to take more time and they're going to cost more money. So the simpler you can keep your first product to market, the easier it is to test the market, the easier it is to meet your schedule, meet your budget, and get the product to market in the time that you want. So that'll make everything easier. Getting a well-defined minimum viable product, and then understanding all the risks and trying to tease those out early. If you think back to the cycles of innovation, this is where you can understand what the product does and how you can identify some of the risks. That would primarily be development technology risk. There are other risks, and the most successful companies I work with incorporate and understand all these risks before they go to market, before they bring the product to full scale. A lot of technology-based companies tend to focus on, does the technology work? Does it meet the features? Can it do some cool things? But biggest risk that I've seen over the years is market risk. The second biggest risk probably is on the regulatory side. A simple example is the first company when I came to the Bay Area was called Raynet. It was very sexy optical telecommunications company, and they had an optical transport where instead of having to cut a fiber, you could bend a fiber and you could read a signal on and off the fiber. And they developed a topology for that product, which is called a loop. So you could take the fiber and then you could read a fiber and then you could continue that loop and you could put maybe some number of homes, maybe 8 to 10 homes on one loop before the signal eroded. And that was really innovative and a great technology accomplishment. What they didn't realize was Belcor, which was a regulatory body for that, for telecommunications product, would not allow that topology, because if you broke the fiber early, it would knock everybody down later. And after 3 years, $300 million of investment, they had to change their topology because they missed regulatory. Well, it took them another 2 or 3 years to redefine the product, or another 300 million. And by the time they they sold the business to Ericsson. They had invested over 600 million and they sold it for around 30 million. So again, it just illustrates the point. If they had just understood that regulatory thing, which would not have been hard when they were small early in the stage, they could have saved a lot of time, a lot of money. So, and these things apply to everything: market, regulatory, supply chain, manufacturing, distribution. So each one of these can either make your company or break your company. And then the other aspect is flexibility versus control. When you're early on in the cycle, when you're in this feasibility stage, you want a lot of flexibility. You know, tinkerers like to tinker, and that's great when you're in the feasibility stage. When you get closer to shipping, it's really important to have controls on your documentation, controls on your design. They call it design freeze. Get systems like product lifecycle management systems in place. So flexibility definitely important early on, but as you get closer and closer to shipping that product, having control, having documentation in order is critical. Yeah. Okay, going to talk a little bit about design for excellence. This can mean a lot of things to a lot of people. Typical categorizations that apply to design for excellence include design for assembly, design for cost, design for manufacturing, design for test, design for serviceability, design for supply chain. And all of these are important to take into consideration as you transition from engineering design, engineering validation into full-scale volume. All of these have a direct impact on cost and quality of the product. Okay, and why is it important? You want to scale. It's a key element for scaling. It's important for sourcing, product quality, reliability, and managing your costs, meeting your cost targets. All right, so let's talk about cost escalation. This is very important, especially for those that are more in the software development space and the hardware development space. If you think about making a change in software, let's say you're distributing 1 million copies in the software space and you have an error, something goes wrong with the code, maybe there's a bug, whatever, you have to make a fix. These days, it's as easy as fixing the code and then hitting a button. And if you do that right, people do an upgrade on their system, and then they have a million deployments, and everything's fine, no problem. The cost is low. You may have some brand erosion, but the cost of doing that, implementing that change, is really not a problem. If you have a problem in a hardware product, let's say, for example, if you remember the Samsung phone that had the battery that was blowing up. The only thing you can do in that case is ship it back and replace it, or figure out how to repair, send a new battery and repair on site. Any one of those options is very costly because it's not hitting a button and updating software. Every hardware you have to touch, you have a part to buy, you have to replace, you have to repair, there's a cost. So not only do you have the brand erosion, but you have a big cost impact on the business and a big time delay. You have to buy material, you have to stock material. And I spent 8 years running a manufacturing company, and these kind of repairs were very painful, not just from a time and a cost standpoint, but also every time you touch a hardware product, you're gonna impact potentially the reliability of that product. So, and then you'll have problems down the road. So the key takeaway here is do it right early. Go through those cycles of innovations before you get to scale. And then if you do it right early, you're not going to have these problems down the road. Okay, and then getting a little bit wonky here, but into the weeds, there's just some tips as you're designing your hardware product. Getting a solid part numbering system, product bill of material. I call this foundational. This is a foundation for scaling, important for keeping track of what's going into the product, and then as you go into scale, being able to communicate that information into the supply chain. Just good design practices. The less parts you have, the less fasteners you have, the easier, the more reliable the product, the lower the cost it's going to be to assemble that product and ship that product. So where possible, eliminate fasteners, minimize parts, minimize the number of parts. Consider the total cost of each part, reuse where possible, especially when you're going into next generation of products beyond the first, think strategically, think of logical sub-assemblies, and think of how can you reuse parts over multiple cycles of generations. Get parts with second sources where possible. I don't know if anybody's directly been impacted by supply chain shortages, but it is a huge industry right now, and it's not getting better for a long time. So finding alternate parts where possible is gonna make it easier to assemble products, buy parts, and find alternates if your current part goes on allocation or gets obsoleted. Also, apply concepts like poka-yoke. They call it mistake proofing. It's a Japanese terminology. Think about in your cell phone, the card that goes in, it can only go in one way. That's mistake proofing. A few years back, I was at a company that had a high power inverter, and we had cords that could be reversed, plugged in the wrong way. And when you have an inverter and you plug things in the wrong way, they explode. So definitely don't want to do that. I have seen this applied very well over the years. So if it's possible, and generally it is, to define only one way to assemble, it makes it a lot easier to get higher quality and to manufacture the product in a volume production environment. Okay, and the other thing is design for testability. There's a lot of layers of test, ranging from board level test, in-circuit test, subsystem, system, and then full system test. And test generally, when you're talking about scaling a product, is going to be the highest cost in production, and it's gonna make sure that your product is not going to fail in the field. So understanding tests, getting it right, getting it designed in early is really critical. Another company I was at, that same inverter company, wanted to save a couple days in the development schedule, so they didn't put in an in-circuit test, which is a very fast 30-second test. And I was running production at the time, so I ended up with a 15-minute production test that did not do in-circuit test, and I had to live with that for 3 years. Our volume was about 1,000 a month. So think about the difference between if we had added those 2 days early, a 30-second test versus a 15-minute test for 3 years, over 1,000 a month. Huge cost impact. Not to mention, when you're only testing at the functional level, it's very hard to debug and figure out what's going on. So understanding test strategy and looking at designing test points early in the design process. My recommendation: do it. It's really important. And then also leverage things like self-test where you can. If you do this, you're going to have better reliability. It's going to cost you less in manufacturing, so your ability to scale is going to be easier, and you're going to have less warranty costs and field returns. Okay, the next thing is additive manufacturing. It's things like 3D printing. Takeaway here is they're there, use them. These are very common, and they can save you a lot of time when you're talking about these cycles of innovation. They can save you time, they can save you money. They're not very expensive, and you can do a lot of rapid testing and really, I look back on before this stuff was available and having to machine out, seal, that kind of thing, really time consuming. This can really help you in the early stages of development to make sure you're on the right track. The other thing that a lot of companies that I talk to, tend to overlook is product reliability. And getting this right, again, it's going to vary depending on your product. If you have a very simple consumer product, it may not be as important as if you're designing for military or space, for example. But the key is understanding it and then defining a reliability plan that's going to meet the needs of your product. And there's tools like calculating mean time between failures for components, failure modes and effects analysis, which is understanding the risk and mitigating the risk, and then leveraging actual testing labs to do highly accelerated life testing, highly accelerated stress screening. These are all tools that are going to help you get the product to failure before you ship it, understand where the failures are going to occur, and then mitigate the risk before you actually start shipping the product. They will result in higher quality, and they will help you extend your product life. Okay, moving on to agency compliance. Also critical. Seen many products really get caught up. I mentioned the example earlier of Raynet, but think of companies like 23andMe that were trying to get one past the FDA. How'd that work out? They got put on ship hold. So again, this is very critical, fairly easy to deal with early on, very difficult to deal with later on. I was recently, within the last year, working with a company that I would say was on the margin on electrical product on the FCC side, the wireless testing, and they were just below the margin. So they designed it, thought they could pass. They put it into testing. They failed. They had to go back through another design loop that took a couple of months. They failed again, had to go through another design loop that took a couple of months. Six months later, they did end up passing, but it was very time consuming and very costly to the business. So if they had just designed within a nice tolerance window and not tried to be a corner case, they could have passed first time out of the chute, and then they could have hit their budget. They could have hit their schedule. Okay. The other thing, environmental. Every day, environment's getting more important. We should all be aware of it. The regulations around it are also getting more important. So making sure you're in compliance with things like RoHS, REACH. There's plenty of others out there as well. But the takeaway here is understand early what you need to comply with, and then have a plan to make sure you're going to be in compliant. It's going to save you time. It's going to save you money. Okay, the next thing is understanding business systems. And there's a couple concepts here. One is we've been talking about earlier things related to the product. This is now talking about things related to the business. So when you're bringing products to market, getting the product right is critical. When you want to scale a business and run a successful business, getting the data right, getting the business system right is equally as important as getting the product right. So I'm going to talk a little bit about that. When you're talking about product data, things like product lifecycle management systems. When you're talking about scaling a business, things like ERP systems. And when you're talking about a large set of customers, things like customer relationship management systems are all important, in addition to the standard design tools, the ECAD tools, electrical CAD and the mechanical CAD tools. And getting a strategy, getting a plan in place early is really important. And if you want to know why, the next slide really illustrates that. Because data is really transitioning all over from when you originally created in the CAD environment. It's going to then need to go into some form like a PLM system, maybe a CRM, ERP, and ultimately, as you get into scale, it's going to get transferred to your manufacturer, where they're going to track it with an MES system. Most of these systems are going to be dealing with some elements of data that are the same. Which is why an integrated strategy and an automated strategy is very important for keeping accurate data, as well as providing a foundation for your company to scale. I've done a lot of stuff on data management over the years, and the biggest issue I've seen is companies either don't install the right systems at the right time, or they don't integrate them. And what ends up happening is they end up manually entering data in multiple systems. And getting the data wrong. Having been in the manufacturing world, what does that mean? It means you're going to build the wrong product. It means you're going to have to then rework it or throw it away. So getting the data right and then getting the integration right are very critical. The last thing you want to do is be manually entering the same data in 3 or 4 different systems and risking data integrity errors, and then manufacturing the wrong product. Yeah. I'm going to just take a quick pause and say I've covered a lot. So I don't think we can take questions, but I'll just let you digest a little bit, and then keep on moving into the chain here. All right, now we're moving a little bit now.
Mike, I put in the chat for everyone to start, keying in some questions. There was a question that came in, so would you like to take it now, or you want to wait till at the end of the?
We've only got 2 slides to go, so yeah. Why don't we just get the last couple slides here, and then that should give us. I don't know how much time we have left. Yeah, that should give us plenty of time for questions. So. Yeah,
plenty of time.
Okay, so yeah, this is moving down into the manufacturing, but please feel free to put questions in the chat, and then I'll happy to address. All those questions at the end here. So, all right. So next best practice is DFX. We talked about it earlier. are you really ready to scale? So you've done development, and maybe you're through some testing, and this is a little bit of a checklist that will tell you all the things you need really to say if you are ready. Things like DFX. Have you got your prototype production tooling together? Do you have your test plan, test fixtures ready, production test fixtures ready to go? Have you got a regulatory plan? Have you achieved regulatory compliance? Have you got all your documentation, change management systems in place? Is your data organized? Is it ready? Have you got your manufacturing docs in order? Have you trained your people on the production floor? Do you have your sourcing strategy in place? Final packaging, distribution, and the key here is lessons learned. If you think back on those iterations of innovation, have you really run this product out, and is it really to get to scale? Okay. And then this talks about the cost of material. The takeaway here really is get an understanding of what material you need and lock that in early. Once you lock in, for example, an integrated circuit in your design, changing that once that's locked in is almost impossible without a full product redesign. So, doing the testing and feasibility, making sure you have parts that are the right parts, getting second sources is critical, because once you lock that in, making the change down the road is going to be very hard. Yeah. Okay, and then I'll end it with some tips for developing a resilient supply chain. Again, as mentioned earlier, supply chain right now is really challenging. I don't see it getting better probably for the next couple of years. What happened, I think, is IC manufacturers were conservative in COVID, but IC demand increased. And now as demand is picking up, there's just not enough capacity. It takes in the order of 3 to 4 years to build a new fab. So, I think, and then things like electric vehicles, solar, et cetera, are using more electronic parts than prior. So this supply chain thing is going to be a challenge for some time. Be aware of that if you haven't seen it already. In terms of developing a resilient supply chain, what are some best practices? Understanding end user market locations, capabilities, politics, tariffs. Think about China. That was a great place to manufacture until all of a sudden there was 25% tariffs put on. So, not that this is easy, but understanding the geopolitics trying to navigate is will be helpful. Utilize standard short lead time parts in design. That's going to give you flexibility if you do run into shortages, if you have short lead time or second sources, it's going to be easier. Stabilize the design prior to scaling into volume. I've done a lot of manufacturing. I've done a lot of scaling. Last thing a CM wants to see is a lot of ECO changes. Very difficult to implement. CMs are not really designed for change. They're designed to build the same thing over and over again. So you want to have that design very solid before you really go into scale. And when you're selecting your suppliers, really consider things like the fit of the technology, the culture, volume, support, cost. Are you hitting all the things you need to hit? When I help in this area, we generally create a matrix of all the critical factors for selecting a supplier, and then we'll map those into 3 or 4 suppliers and make sure that the fit is a good fit for the business. Tier 1 is not necessarily the best fit for all companies, and tier 3 is not necessarily the best fit. So you've got to do what I call right size the manufacturer to your business. Also consider things like financial stability, size, and ability to scale to your needs, especially if you're an earlier stage company and you want to scale. You want to make sure that CM is going to be able to meet your needs. Where practical, duplicate sources. This is a tricky one because duplicating suppliers can be expensive. So this is a trade-off you just have to look at and say, does it make financial sense to do that? If you have enough volume and budget, yes. If you're early on, it may not be practical early on. Communicate clear and predictable production volumes. When I was running production, this was one of the biggest challenges we faced. Companies were always overly optimistic. They would say, hey, we're going to build 10,000, and then they would build 2,000. But if you're on the OEM side, if you're on the development side, the challenge there is you're committing to dollars when you're putting a schedule in front of a manufacturer. You're actually committing dollars. So whether they build 2,000 or 10,000, you're going to still pay for it. So getting that right is really critical to manage your cost. If you get it wrong, you're gonna either end up not having product when you need it, or you're going to end up with a lot of excess and obsolete, which is going to cost you money. Okay, and then the other thing, kind of end it with your supplier is a very critical part of your business. Think of it like a marriage. You know, you're not going to get married and then not talk to your significant other for 3 months or 6 months, right? You need regular communications, especially when you're in that NPI cycle. It could be daily communications. When the product is stable, at least I recommend when you're in a little bit more steady state, a minimum of 3 months for a formal quarterly review, quarterly business review, where you're looking at things like cost, quality, delivery, and ratcheting up quality, ratcheting down cost, and then retooling the schedule and making sure that on-time delivery is there. So I'll end it with that, and I'm happy to take questions. I think we have a few minutes left for that. And if you do want to contact me, we went through a lot of information here. Each one of these slides could be a day or two presentation in and of itself. So this is a very high level cut. I'm happy to talk deeper if anybody does. So feel free to reach out. And then why don't we let's go ahead and jump into the questions. So I don't know if I can see the.
There's a question from Dave. Let me look at, regarding
chat. Here we go. I got the chat.
Yeah. Yeah. So
okay.
12:34. The timing. So if you scroll down to Dave.
Let's see, Dave. Okay, question. Yeah. What are typical ratios between material cost, manufacturing cost, total cost, life cycle cost, and selling price? Yeah, that's a great question. It's really going to depend on your product. So a typical high volume consumer product that I've seen, your material cost could be on the order of 80% of your total manufactured cost. If it's a much more complex product that has a lot of manual work, that could go down to maybe 50 or 60%, something like that. So that's going to vary depending on complexity and volume. And then again, life cycle and selling costs are going to be very different depending on what kind of company you have. If you have a consumer product and you need to do a lot of advertising, your marketing, selling could be very expensive. If you're selling to government and or IC industry and you have a few clients, that could be a lot less. So yeah, so this is really going to vary quite a bit depending on your product, depending on the markets that you're hitting there. But I would say generally consumer products are going to have a much higher material cost relative to the other costs because you have a lot of volume, but you're also going to have higher marketing, selling costs. If you have selling products into more more B2B, then generally you're selling your marketing and selling costs are going to be lower. Yeah. And hopefully that answers the question. Any others? Okay, Malcolm. How do you help companies find the questions they do not know to ask? Well, that's a great question. I mean, I think this presentation is intended to do that. I've also created a lot of content on our website, on our blog. We've got some of this on now video, the 8 best practices. So I think it boils down to education and also. When I work with a client, I have an onboarding questionnaire that goes through a lot of these things. So if you ask the right initial questions, you can typically understand where the gaps are in the business. If you go back to the warning signs and you have questions that map to those warning signs, then it will typically educate the client on what questions they need to ask. Let's put it that way, and really where the gaps are in the business. The other thing I wanted to mention is I do have a handout. I don't recall if I sent it, Joseph, to you, but I will send that to Joseph and the IEEE folks. So it summarizes the 8 best practices in a 2-page handout. And if you want to email that out after that may be helpful. or if you want to contact me directly, I can email it to you. Yeah. You mentioned 25% tariffs for products made in China. Yes, I believe. I don't claim to be a tariff expert, but I don't think those ever were changed. Yeah, I mean, Joseph.
Yeah, still in place. The new administration haven't removed it yet. So let's go back to the IC supply chain. I think the chairman of TSMC was on TV talking about that. They trying to make up the shortage, hopefully within 1 year. So so for companies that so I've been getting anecdotal, so it really depends on what type of chips, what kind of IC. So I've just recently talked to one startup company. I mean, one of the components that they were looking for actually went up 10x. So it's not just lead time; it's also the cost.
Right, and just to add to that, I mean, my experience, because I was working in a contract manufacturer the last time we had component shortages. The other issue you get into is not only increased cost, but companies that really want to build product, they'll buy on the broker market, and when you buy parts on the broker market, there's a lot of risks with component failures and bogus parts, counterfeit parts. I mean, you get into a whole messy situation when you get into not able to buy the right part from the right vendor, and you have to make it up. Somebody mentioned cybersecurity. Absolutely agree. This presentation really wasn't focused on the software side of things. So yes, you're totally right. And I'm sure there's another presentation that could talk all about how software ties into hardware and integrate Internet of Things. But when I think of cybersecurity, I think of that more of a software element, and I have not talked about it here. Yeah. Are you seeing supply chain issues in the area other than ICs? Yes, there are supply chain issues in everything. It's a very messy supply chain right now. Fabricated parts, raw materials. It's very messy. Yeah. Yeah, I think Modi said cybersecurity is also hardware. Yeah, well, sure. There are hardware parts tied to cybersecurity, but again, this presentation was really around the execution of building a hardware product. Yeah, so I'll leave it there. I'm happy to talk offline if you want.
Yeah, I think we can, like in my slide deck earlier, any topics that you're interested, feel free to send it to me, joseph.way@ieee.org. Actually, cybersecurity covered both, actually. Also, not from the actually manufacturing or the product design, also your company infrastructure. I mean, because of the case with the oil company in Southeast. So, so just saying cybersecurity is a very big topic.
Yeah, I think that would be a very relevant topic, and I totally agree that's going to be a bigger and bigger issue as we go forward. The more connected devices there are, the more risk there is for cybersecurity issues, especially when you're talking about not just computers but IoT devices. The security of these I think they vary widely. My experience, there's a lot of companies I've seen in the IoT space, they don't think much about cybersecurity, and then I think there's risk out there we don't even know about right now. Yeah. Can the product realization do plastic injection molding, or do you outsource that? Well, we don't. We're not a manufacturer. We are experts in new product introduction. So we would help to identify plastic molding houses that would fit your business, and we do that. We do that all the time. But we are, to be clear, we're a consulting company, not a manufacturing company. So we would help to find the right company to fit your particular needs, and again, that's going to depend on product, region, volume. I mean, there's a whole bunch of things that go into that decision. Yeah. All right. Any other questions?
No, I think you have touched upon a lot of good points. So without any, that was the same question. So yeah, we're coming up to about 1 o'clock. but let's see if anybody else has any other questions to ask.
Give it just another 30 seconds, and if not, I want to thank Joseph, IEEE, and Rio for organizing the AV side of it, making this smooth, and thank everybody in the audience for your participation. It's been a pleasure to present here. Yeah.
And please come to our website. I think we already have another speaker. I think we have like 3 speakers already lined up for June, July, and August. I just don't remember off the top of my head. So if you subscribe to our email list, then you'll get notification of our next webinars. So thanks for everyone thanks everyone for attending this webinar, and thank you, Mike. You've provided a lot of key insights into the whole product realization process. And I'd like to thank everyone for attending. And Rio, you can stop the recording, and see you next time.
Okay. Thanks again, guys. Take care.
Thank you.